Hello, everyone. Welcome to my next devlog for Project Ambrosia. As you can see here, I have a screenshot that I pulled into image editor that I like to use called Affinity Photo, and I just drew on the screen to kind of get an idea of like what interacting with NPCs kind of looks like. As you can see here, I have like different colored circles that would represent the enemies and the NPCs that are neutral and maybe any allies. And then I thought that maybe like I could have the player run some kind of collision check around it. And maybe when you select a NPC, they would show a tag that maybe holds their name, maybe their HP, maybe their combo points and all that. And then I noticed that I also wanted to have logic for each of these NPCs to move themselves between each cell, right? So you could have, I don't know the logic exactly, but maybe a prowling tiger could go across certain cells in a certain fashion and they would follow the same movement rules that the player would. So I thought, well, I mean, this is probably a great use case for taking the movement system that the player has and applying it to a generic NPC object that looks similar and does similar things, but doesn't do everything that the player does, right? So then, with that thought in mind, I went ahead and produced this. So as you can see here, I have a couple NPCs. This is a neutral, this is an ally, and this is an enemy. And they all seem to have a new set of arrows, just like the player. And that's what I'd like to focus in on this devlog is what I call the actor direction helpers. So when I open this up, as you can see in the viewport, it's a similar structure that I had inside the pawn, but instead I've extracted it out into its own thing to be pulled into other pawns. Pardon me. So what that means is I had the challenge of figuring out what encapsulation looks like in Unreal Engine 4. And the reason why I'm doing it this way instead of like using a inheritance model is because I read somewhere on the Unreal Engine 4 documentation that composition is favored over inheritance. And I think that's a better model in general, just for programming, so that you don't have to deal with complicated nested ancestries. Even though it's used like heavily on the back end, I'm sure it's just because Unreal Engine is just a very old platform in general, so they probably rely on that a lot. But that doesn't mean we have to stick with it, right? So here we are. So looking at the direction helpers, one thing I wanted to do is say, okay, I'm a pawn or I'm an NPC. It doesn't matter which one I am. I need to go in a certain direction, or even more basically, I need to get information about a cell in a direction. So I established these helpers to point at the proper cells when you're at the right height, above the cell. At some point, I might actually do some math to point these in the right direction if I change the overall like height of a object that's using it. But for now, I just left it like this. And then in the construction script, I set up a map. And what this does is it just stores all the direction objects and keys them according to the cell connections enumeration, which is going to be north NSEW, correlating to the direction I care about. So this allows me to loop over those directions when I need to. I set up this event graph, right? So right here, what I'm doing is I'm invoking an ES event, and just to a shout out to the developers of the event system on the Unreal Engine 4 Marketplace. The team is called Out of the Box, and they really helped me out with using their systems to really help me decouple things in my project, and I'm actually starting to really enjoy the project now, and I'm super glad that I invested in it. So with this event that I defined in here, so it's called on request cell in direction. Again, I didn't configure anything else besides just a name. What I've done here is set up a payload as well. That's really the more complicated part. So I just set up a payload cell, and that holds a reference to a cell, the direction you're asking for, and a comm channel. And that'll be useful later. So here I casted the cell, I grab the values I need. I need the direction to know which direction I need to raycast in. Once a return comes through and it's valid, it gets added back to another cell payload. As you can see, you don't see it yet, but when it comes in, there's no like cell reference being passed through. I'm just using the same payload for the entrance as I am for the exit to keep things more consistent. And then the comm channel and direction are just passed straight through. One's only used, the comm channel is used on the other side to make sure, to delineate like different uses of this same event. And I'll show you that in a sec here. So we set up the instigator so that the other side knows, has a reference to the object calling it. And we also set it here. And the nice thing about this is that we call another event called onResponseCell in direction. The method to do the raycast is pretty much the same as it was before. I think I found that I don't even need this anymore for what I'm trying to do. So then we go back to the pawn that we had before. It's refactored now to use the new direction helpers. As you can see here, it's just placed in there. And then when we get to the construction script, no, that's not it. I do a similar thing here. I might actually make this a global variable, which is actually another event system. Not another event system, but it's another system that's provided by out of the box, and I have it installed in this project as well. And I'll show you how I'm using it here as well, but it allows you to provide global variables to all your components as well, easily referenceable. So I could totally potentially use that to make that a global item. Well, maybe not, because I need these references to be local. So for every instance, I need this. So yeah, this is fine the way it is, but I do use that system elsewhere. And where I use it is in the, I believe, update pawn location right here. So I wanted to globally manage the height that a pawn or a NPC object hovers over the cell. And what that does here is grabs from a list of defined float variables, and I use it in the calculation for where they are above the cell, essentially. Otherwise, that function is the same as it was before. And this is the usage of the event system. So when I call gets cell in direction, what happens is we construct a cell payload and we invoke on actor. Now, just a side note, eventually this invocation will probably get updated with a later release of event system so that you don't have to define the whole payload. You can just pick a payload and then hook up the pins from there like you can with the normal global event invocation. But for now, I get my reference to the child actor of directional helper so I can get a direct reference to the blueprint. I send it through to this actor, and that way it's not globally triggering everything. So it's just this pawn's reference to its actor. And then I make the request. So after the request is made, what happens is over here, it listens to it, does its thing, boom, goes all the way through and makes a call back. And then we have on the other side a listener to this event. And what's nice about this too is that I'm invoking on actor again, but to the actor that was invoking it. So we get the instigator from that payload, pass it in so that it responds straight back to its, it doesn't even have to be a parent anymore. It could be whatever instigated the invocation upon it. So it's nice, just a nice way to not have to go this dot self dot parent and then hit the right thing from there, and then from the parent go to this dot child and do that. You're just kind of managing who is, just responding back to who called to you, which I find to be a great way to structure things. So it calls back, and over here we listen to whenever we hear a response in a cell direction. We get the payload like usual. I store the chosen cell from the payload, and then I switch on cell comm channels, which is an enumeration I set up to manage the different channels that we'll probably have to deal with to get this going. Because what I found was that I wanted something to happen with this functionality on pawn start, on interaction, and also I needed to split up the information gathering steps of getting the current cell and going to the next cell. And the reason for that is when you need to go to another cell, we need to first know if you can go there. So in other words, when you're in this cell, if I wanted to go west and there's a cell there, but there's no connection. So for instance, if we go up here, let's say you're in this cell, to go to the west cell, you need to go around because there's no actual connection to it. So I run a raycast to this cell with the same function. I get a response, which returns to me the list of connections that are allowed, and then it can take me to the next cell. So if it's not there, I just stop right there. I don't go further. But if I can go in that direction, what'll happen is it'll do another cast in that direction, and then I can get the information about the position of that cell, and then also its description and all that goodness. So what that looks like is the first invocation is here when cell starts, or the pawn starts. So I send that through in the channel pawn start. It comes back through, pawn start comes back through. We update the pawn location to get it to the right height. We update the UI to add it to the viewport. And I could probably move that up there actually, but continuing, we can invoke a description update as well. And since we have the description update associated with this chosen cell, it works. And then after that, I choose a direction with my controls. I hit my interaction button, and it does a direction down, same as before. But it also looks at the current cell channel. And when it does that, we go through this bottom current cell branch, and we see that we've pulled from the invocation the allowed directions, and we look for the current direction in there. And what this does is allows us to, as you can see here, where did we define that? Let's see. So the target map cell. Oh, right. Yeah, that's the helpers. So we pulled it from the map cell. So map cell, when we are constructing, I set up a similar thing I'm repeating over and over. I'm probably going to encapsulate at some point. But what it does is it also sets up a enum'd key for a Boolean value for each one of these directions. And then I can go through, and depending on the flags that I've set up in the editor, I can hide and show the directions and also adjust based on the settings I have currently. And then I just use this array again on the other side. Well, this dictionary again, this map. So what you can see there is, for instance, if I hit this and believe I've called this, yeah, here we go. So as you can see, thanks to that, I'm able to just actively hit these check marks to update the paths without having to go through and go visible, invisible on the rendering thing. So that's a really nice thing that worked out. And then I use it to set the visibility. That value is reused here to see that the direction is available for the player to move in. If it is, they go in that direction using the next cell channel, passing in the direction, and it goes through here, updating the description, and then moving the pawn to that location, animating it to that location. Otherwise, it just doesn't go anywhere. And maybe here I'll have a message that says, hey, you can't go in that way at some point, but that's how that works. I'm able to reuse the same event in many different ways so that I can reuse the code that I had before. And then I can use that exact same cell acquisition logic over in the NPCs. So on the NPC side of things, when they begin play, they get the current cell. And in that direction, I've updated it so that it will update its location, like its NPC location above the board. But what it's also doing is it's moving the mesh to a part of the cell so that the functionality for the cell direction helper doesn't change, but it still visually looks like they're in another part of the cell. So here I set the spawn point, which is where I set it initially in the editor here. So I put one there, there, and there, right? And then I go ahead and set the transform. I switch through, depending on what type of enemy you are. I have a switch for that. And I set a material for the color that I'm expecting. And this will probably expand in the future, but it allows me to just make it to where the same object can be used for many different things, including being interactable, which is going to be in a future video, having that happen. So that is an example of reusing the same component across two, as you can see here, like there it is in the viewport. They're able to detect what cell they're in, and then they're able to detect what cells they can move to in the same way that the player can, but I didn't have to inherit that functionality in the same way. I might compose, like I mentioned before, a lot of the functions that I'm reusing here in a future video. So yeah, where that puts us now is, what do we have here? I also have a nameplate, which is an actor that pulls in you won't be able to see it here because it's hidden by default, but it pulls in a UMG, which pulls in just nameplate. And it just looks like this, simple. I put that on the NPC character so I can eventually set up a name and health value for that NPC. And then in the future, the idea is that would decrement or something like that to check on that. Only other thing that I think is worth going over is that I did set up a combat tick for the game, and I'm going to use that in future logic, which all I'm doing in that is just setting a timer function, I should say. Timeout's a web thing. And I'm looping every 1.5 seconds, right? And I'm invoking this function, which just fires a straight up event without a payload. And then any object in the scene can listen to this event and do something when the tick fires. And I'm using it in the pawn here to just print a string. So we'll see a combat tick print in the log in the upper left. And the last thing I was trying out that I got working was that when I press T, I noticed that when I press tab with a UI element on the screen, that it would kind of cycle through those elements. So I switched it to T. And when I press it, it does a multi-box trace by channel. And then I set up a channel called interactable. And I made my NPCs block on the interactable channel. So if you can see here, I believe if I hit the class defaults, I should be able to. There's usually a collision aspect to this. I think I put it on the mesh actually. Here we go, yeah. So the collision, I set it custom, and then it's going to block on the interactable channel. So what that does for me is when I press T, I get the default scene root, get its transformed so I can grab its location, and I get its forward vector. And what that is going to do is establish a starting point for me in the world, and then the vector allows it to go in a certain direction in the world. And I'm just using the box size, so it's going to be 140 units wide, tall, and deep. And that will allow me to just basically roughly scan everything within the cell bounds. And I'll show you what that looks like here in a second. So let's get back into it. So as you can see, each of my NPCs has a nice little text block, name tag and bar. They're in the right positions. and they're floating above at roughly the same level as the pawn right now. I also did some adjusting to the lighting. As you can see, the ray casting still works. And the perspective kind of makes them shift downward. My intention is to make it to where they kind of fade out from view once you're outside of the cell. And then, as you can see in the upper left, the combat tick is firing every second. There's an on-cell enter event also firing. And here's the other thing where there's another cell that I could have gone to before. I'm pressing my interact button right now to go to it, but it's not allowing me because there's no cell connection there. Pretty cool. And then if I go into here, there was a cell connection that allowed me to go into here, but there's no cell connection that's allowed me to go out of here. So I've essentially set up a trap cell. And maybe I'll add functionality later on to where you can figure out how to get out of a trap. All that good stuff later on in the future. So I wanted to thank you for watching, and I'll see you next time. Bye-bye.